I have a different experience in blue team, like penetration tester, like a software developer. So just to, I want to know something about you. How many of you know serverless or like AWS, Lambda, GCP function? Okay. And how many of you work with the serverless daily? Okay, less. Okay, what I want to share with you is try to show you something about the attack vector in serverless application, a new attack vector, and share what happens when someone exploit a vulnerability in a serverless application. Because we think, in contrast, we understand that there is a different step after the first exploitation of an application in serverless environment. So when we talk about serverless, it's not only a changing in how we build application or which kind of architecture we have in the application itself. Of course, it's a big change because we move from the legacy monolithic application to microservices in a system that have many microservices, many micro functions. The Lambda in AWS is only can be only a method of the code. So we have different micro components that communicate each other through events, through API calls, through queue. And so the complexity of this kind of architecture grow up because it's more difficult to have a good observability of this kind of application, to understand the behavior of this application. Also, the development process going to change because we don't have anymore the semantic versioning of an application. We don't have anymore the 1.0.0 application because every component will be upgraded each time, each component, many times in a day. And the challenge here is upgrade the different components in different time and have an application that continue to work. It's not so simple. And so when we're talking about serverless application, we also think to change the way the developers do their job. So we introduce, everyone I think know about DevOps, and of course, in our point of view, better if we talk about DevSecOps. Introduce in the process that deploy, install, upgrade the application, all the security verification needed to be sure that our software is not vulnerable. And also, we are going, to change the development cycle, but also we are going to change the process of development. We need to automate all the steps we need to upgrade and to install a new application. And in my opinion, I'm kidding, the more dangerous part, change the decision, how we make the decision in development process, moving from a top-down process with a bottom-up, give more responsibility to each developer to make choice, to change the application, to upgrade the application. And this is dangerous, I think, because I was a developer and sometimes I did not a good job. So we are here to talking about, again, serverless security, but why I make this long introduction In contrast, we play with Google Trends. Sorry for the Italian. I take this screenshot yesterday, and I have the location of the browser in Italy. We usually try to see the Google Trends about how many people are looking for serverless. And we can see that the blue line is going up, except for the COVID period. That's maybe there is another kind of interest in that period. But what about serverless security? Again, it's looking like there is no focus on security in serverless. Yes, because we think the serverless paradigm shift the security responsibility from the customer to the cloud service provider. Because in Lambda, for example, in GCP function, you have the responsibility only about the code and what you install inside the Lambda itself. In this case, the runtime, the server, all the configuration are responsibility of the cloud service provider. The risk here is to have a false sense of security in serverless application. Because, OK, I put on only my code, and everything is OK. All the other things are handled by the cloud service provider, GCP, AWS. Well, but it's not true. Because this is our customer's application, serverless application. It's a really simple little application. You can see the graph that represents all the components involved to make this application works is huge. More than 100 of different services works together to make this application is working. And each component is each node represents a different component inside the AWS. The orange one is Lambda function, so the code provided by the customer. The purple one is API gateway, so all the purple node are represent in API REST exposed internally or on internet. The green one is a S3 bucket. The blue one are all database, different database where the customer data is stored. And the pink one are the queue, event bus, and other system to permit to communicate each other different components. So it's difficult now. I think you can see, understand what happens in different steps of the application. And also, the risk here is to have some issue in the observability of this application. Another issue when we're talking about serverless application is the loss of the perimeter. With the old application, legacy application, but also microservice installed on-prem, usually we have a network infrastructure, well-defined network infrastructure. We have, for example, a network subnet with all databases internally of your network. We have an application subnet with all the web application services, a demilitarized zone with the load balancer, and the perimeter firewall, web application firewall, and other kind of security appliance. When you have an application, for example, need to upload a file, for example, an application to handle the papers, the call for papers for a conference, no? The paper is uploaded inside this application to permit the organization to understand if it's good enough to be accepted or not. In the legacy application, we have a REST API. The the user connect through this REST API and upload the file. The file pass through the web application firewall, arrive in the web application server, and then the web application server, our legacy application, go to store the file inside the storage. In a serverless application, no, it's different. Every single service is potentially exposed to internet. So when you want to upload your paper, you don't communicate directly through a firewall to the Lambda that handles this file. But you have to store it in a S3 bucket, a service provided by AWS, reachable from the internet. The file, when it's uploaded on the S3 bucket, the S3 bucket itself generates a trigger, so send an event to a Lambda to say, OK, I have a new file, take care about it. You know there is a new file. The Lambda should be able to download the file. I don't know what else. So all the system, also the database, are exposed to internet. Of course, your configuration need to block all external communication to these services. But potentially, all the services are exposed. So again, about the observability, to check, to control what's happening in an application, we have more challenges here. We don't have the only one point to access the firewall and the web application firewall. And so, talking about permission, in AWS, I bring all AWS example here. All the resources are protected using the AAM. Defining the AAM define the resources, the principle to define who can access to what, and define the action can be done or not. This is a very simple Lambda provided by a damn vulnerable serverless application. It's a tool to learn vulnerability and security for a serverless application provided by OWASP. And this Lambda is one single component you saw before. The scope of this Lambda is create a new order for e-commerce inside a database. You can see how many? 20 line of code. I want to focus on the behavior. The only things this Lambda will do is create an object, put an item, create an object inside a table, a DynamoDB table, orders table. OK, so very simple. Each Lambda, each resource inside the AWS is executed using a rule. The rule defines what the Lambda can do in this case. In this case, we have the action, DynamoDB star. So this Lambda can do any action in DynamoDB, read all table, write item, read item. And the resource define on which DynamoDB can operate. In this case, all the table inside my demo account. The demo account is the number here, 4021, etc. You can understand these permissions are too large for what this Lambda can do, because I need only put item and only on orders table, a table, DynamoDB table. So to perform a correct approach for this permission, we need to work with a least privilege approach. We need to change the permission to give only the least needed to work. In this case, we have to change the permission with put item in the action. So after this change, this lambda is not able anymore to read what the content of the table, and the table involved. Okay, so it's look simple. Make this kind of assessment, no? Because we read the code, but remember the infrastructure we saw before. You have many lambda, not so simple, not always so simple, and so manually check the manual assess doesn't scale. So we need to integrate a DevSec approach to harden this kind of process when you upgrade, install the code. Okay, so we talked about the architecture. It's an event-driven architecture because we have different services, different component. Each component talk each other with event. The trigger I talking before is the operation that the cloud service provider use to send an event to another service. And when a trigger sends an event to a lambda, and this is we start to talking about what happens under what happens behind the cloud service provider. The cloud service provider spin up a container with inside the code of the lambda and send the event to the code. After this, when the lambda finish to execute, the cloud service provider put down the container. Sometimes, this is another issue. Sometimes AWS reuse a container for performance reason, but in that case, if you save inside the container some information, you risk to expose some sensitive data. So we have to be focused on this. So again, trigger, an event sent to a lambda, AWS run a container with the code inside, and after this, put down the container. And the lambda is where your code are installed. And with your code, often, there is also the bugs. So we change, we change the kind of architecture, all the process behind this new application, new kind of application. And also OWASP redefine the top 10 risks for serverless application. This is the new top 10 only for serverless, provided by OWASP. And of course, we're talking about an event-driven architecture. The first risk is event injection. I want to focus with the other two risks, because I think mainly you know all them. But I want to talk about the denial of service, because maybe denial of service in serverless architecture sounds strange, because if I have a Lambda in AWS to put down this service, I need to put down all the AWS infrastructure. So I think it's not this the case. But we usually talk about denial of wallet. So an attacker that wants to deny your application, make many calls. So your Lambda is run by the AWS many times, and you're going to spend many money for that. So, and the other one is the insufficient logging and monitoring. Yeah, because many times I'm working in COC and in the blue team of a big fintech in Italy. Usually we are focused on take the log from the server, take the log from different applications to understand what's happened. In AWS, often the default log are disabled, so we don't see anything. Usually we see only the CloudWatch logs from the Lambda itself. It's not an issue by AWS or other content service provider. they give us the service. All the vulnerability I'm going to show later with the demo is provided by the code itself, and library used by the code. It's not vulnerability provided by the cloud service provider. This is an important point. So about the responsibility in serverless is always your responsibility, the code and the library that you're going to use. So the risk to have insufficient logging and monitoring is very high, and we need to focus on this. So I'm going to suggest some tools to help you in the development process, and then we try to see something for real with a demo. The first one is provided by my company. It's a CodeSec. It's a tool that run on the Lambda, Python, Node.js, .NET Lambda, and try to identify the least privilege permission you have to use. So we think is a good help for the developers. The other one I already talked about is a DVSCA, is provided by OWASP. Is a full functional serverless application with many vulnerabilities inside, and I think it can be useful for you if you want to try to make some bug bounty or test with a real serverless, functional serverless application. It's an e-commerce, video game e-commerce. Okay, last faster recap. In AWS Lambda, we have inside the container that executes your Lambda, we have a read-only environment, except for the TMP directory. It's not wired to internet, but it's able to reach internet. So externally, you cannot reach the container, but the container, when you exploit a vulnerability, can reach the internet. All the data inside is temporary. In the time the container is up. So if AWS reuse the container for performance, the data copy inside remain in the follow execution. The code is inside the environment itself. So if you have an vulnerability, an LFI vulnerability, you risk to lose the privacy of your code. And also, the key with the secret that permitted to the Lambda to authenticate with the AWS environment is inside the environment, the environment variables. Sorry. So if you have, and I will show you, if you have an exploit that exfiltrate the environment variables, the attacker can impersonate the Lambda itself and run every command like the Lambda. Okay? So, always awake? Okay. The first demo. We are going to work with I want to show you the first vulnerability is not a code vulnerability, but a vulnerability inside a library that we use to create, to deploy this Lambda. I think you remember log4shell, spring4shell. Okay. We created this Lambda with Spring, and I'm going to exploit the Spring Express language vulnerability and see. We doesn't care what the real Lambda did, because the vulnerability is before the code of the Lambda, because it's present in the part of the code that understand which kind of function could be run after the call. Okay, so I hope the God of the demo blessed us. Two steps. The first step, I want to show you I show you two tools I developed, two simple tools that help me to test the code, test the Lambda in the AWS events. The first one is Mawike, is an event injector. take an event, a JSON event from the standard input, and invoke a Lambda, or I support AWS Lambda, a GCP function, and invoke the function using the event I sent in the standard input. So this one. I will show you before the event. To simulate the API gateway, I create this JSON file. Okay, it's too small. Just a second. Okay, this is the same JSON that the API gateway service sent to the Lambda when someone make a request to the API REST. In this case, the header, this one, is the actor vector for this vulnerability, because if we insert inside this header value the payload, we are able to run remote code. So, first one. The first run usually is slower, because AWS needed to build up the container and send the event. And we have here the body, because the header call the uppercase application that return the input, the input in the body, and convert it in uppercase. Very simple. Okay, now I'm going to change the event and use this one. It's not so readable. Sorry about that. I changed the content of the header. You can see in the top of the slides. And I put a Java code. The only thing this Java code will do is send to an IP address my server to a TSP port here. Send the output of this command. Just a second. I try to find the command. Okay, this one. I try to exfiltrate the environment variable, and send back to my server. So I'm going to connect to the server. Okay. See. And I'm going to see what happened. I get all the environment variables from the container itself. You can see here what I talked about before. There is AWS secret access key. So there is the AWS access key ID, and the other one, there is the AWS session token. With these three parameters, you're able to impersonate the function. And so after, if you put these in your environment variable, you're able to run the AWS key with the same permission used by this Lambda. Okay, I'm talking later. So now I want to show you the other tool, always with this vulnerability, is Shell-Eyes. The only this function will do, I need to change the things, sorry. Okay. Is try to recreate a remote shell. Because installing a remote shell in a Lambda serverless doesn't make sense because when the cloud service provider turns down the container, the web shell disappears. So in this case, I create a virtual remote shell to explore inside the container to recreate the same experience of a shell. So I'm going here to connect to the server. Okay. Now we have the shell. I'm going to execute command if the demo god continue to bless us. Okay. I am in var task. Var task is the location where AWS install your code. So I can run ls, and I see all the information inside the container. In this case, I have the access to all your code, and also make the same command. No. Sorry, I'm wrong. Make a mistake. Environ. Okay. And take the same information we see before. Of course, in this case, it's another container, but the role is the same. Okay. That's it. Second demo. This is the video because plan B if okay. We have is a little different. Now the vulnerability is inside the code of the Lambda, so it's a bug I introduced in the code. This Lambda use the YAML to parse a file to populate the table user of another application. In this case, I cannot reach directly the Lambda because the trigger that run the Lambda is an S3 object-created event. So every time I will upload a file in S3, AWS run a trigger, call an instance of this Lambda, and pass it an event. Of course, I also execute this Lambda with the tool I showed you before. But in this case, I think it's easier for you to understand what's happened if I'm going to upload the file. So now change. Just a second. Okay, I'm going quit. Just a second. Okay, netcat. Okay, so we are going to see the content of the file. The first one, the good one, is load the users. Simple. 2 users with different rule in this format, in this specific format. We are going to see shortly the Lambda. So you can see the code. And also in this case, quite simple code because okay, simple code. I take the event from AWS. I take the where the file is uploaded inside the S3. I'm going to parse it and send the data to the method to write in the DynamoDB. where is the bug here? It's here. This one. This library has an issue, and you have to use a secure loader. I don't remember the name. Secure loader. In this case, I can exploit the library and have a remote code execution vulnerability. I'm going to show you. This is the content of the table we use. There is no user now. I'm going to upload the file. YAML, OK. Load user. That's it. Now AWS trigger the Lambda. The Lambda take the file, save it in TMP, so the first risk, and then I have the new user. OK, simple. Now we are going to see the other payload. For example, the same payload I used before. Take the environment variable and put it and send it to my server again. So, very quickly, what's next? Upload file, add file, payload, upload. That's it. I have the environment variable of the container. But just to show you what I talked about before, how can exfiltrate the code of the Lambda? This is the content of the file. A simple ls of the directory var task. Add file. Let's file list. Oops, sorry, make a mistake. Again, I'm going to upload again the file because for each upload, the AWS triggered the Lambda. OK, there is only one file, Lambda function. So I'm going to exfiltrate the code. This one, OK? Again. Oh, cut code. Oof. I think there is. I think I ran too many times the ls command. Now I try again. The goldenness of demo now. OK. OK. So I have the code of the Lambda. So currently I able to understand what this function can do, and I use these details to make another kind of attack. and I'm going to do this now. I'm going to take, now I'm going to impersonate the Lambda and execute a command like a Lambda itself. What the risk here, the risk here is when you run service, when you connect and use AWS service like the Lambda, you don't have in logs any information about who run this service, only the role. And the role is the same of the Lambda itself. So you don't have, the blue team here does not have any information about who really use that service. Okay. Should be interesting now to try to get the variable environment variable, but I try. Okay, add file, the payload one. No. Run again. I need only one. Maybe I can use the environment variable I showed before. I try. So here, just a second. Yeah, okay. Now I'm going to export AWS session token. This is the task with more error prone. Okay, export AWS key ID. This one. And export AWS secret access key.
How long are you valid?
Sorry?
How long are you valid for?
1 hour. So should
Your access key and your
get. That's it. Now I am the function. The role is the role of the function. Now I can many action like the permission can grant me. We are going to see which kind of permission this function has. This is the rule. Okay, interesting. This is not a least privilege approach, not used to provide this kind of permission, because I have the full access to DynamoDB. So now I am the function, and I am able to access to another table. Now I make a list. I scan another table. It's not my table. It's not the table of the Lambda. It's the table of the RCA application. I'm able to see all the users inside that. But also these tables, I can see all the table present inside this account, AWS account. That's it. The importance of a list approach, least privilege approach. So, how many times remain? 5 minutes. Okay, I want to try to show you another 2 videos, 2 attacks that my manager bring to DEF CON that use different attack vector. One is a mail, and the other one is Alexa. I think you know everyone, you know Alexa. So try to exploit with voice. Plan B. Okay. That's it. The first demo. I want to try to show you the final one. Few time to be sure. This is okay. This is the Tal, my manager, bring this kind of attack to DEF CON 21, and I think it's interesting for you to see that also the Lambda code behind a Alexa skill can be exploited to the voice, with the voice. So I try to manually. So
Alexa, run DEF CON demo.
How you doing? DEF CON.
Great, thank you. What is my balance?
Who are you?
DEF CON.
What is your account ID?
1337.
The balance for account ID 1337 is $15,000.
Great, what is my balance?
Who are you?
Punk.
What is your account ID?
0419.
The balance for account ID 0419 is minus $350.
What is my balance?
Who are you?
Admin.
What is your account ID?
0007.
Sorry, unauthorized.
Oh.
that's the comment.
What is my balance?
Who are you?
DEF CON.
What is your account ID?
1337 or true.
The balance for account ID 1337 or true is $1,200,000.
Okay, great.
Okay.
$1,200,000.
Come on, we ain't got all day.
Stop.
Okay.
Thank you. Alexa.
Oops. Okay. So just to show you now, different capability, different kind of trigger. I show you some tools to try to start, to try to play with serverless. I hope to show you also the risk behind the serverless application. So thank you very much. I see only the hand, don't see anything other. So, can you come here? Sorry. Oh, nice to see you.